Hi students, today we are going to learn some of the interesting features of physics of colors. After viewing this, you will be able to understand the basics of colors and also would recognize the beauty of nature. One of the gifts of nature is light. We could see objects around us because light falls on them and gets reflected. Isaac Newton, at the age of 23 itself, demonstrated that white light is the source of all the colors. In 1666, he showed that when a ray of light enters through a glass prism, it produces multiple colors. He then passed these rays through a second prism to reproduce a single ray of white light. Thus, Newton proved that color is in the light itself, and also white light is the mixture of all the visible colors. Modern understanding is that light is a form of electromagnetic wave. The electromagnetic spectrum has a wide range of wavelengths. However, our eyes can see only a short range of spectrum called visible range, that is from 380 nanometer to 750 nanometer. The variation of colors is due to change in wavelength. Each color has a distinct wavelength. Light, as a wave, interferes with the neighboring wave. Due to interference, the two possibilities that arise are: 1. Constructive interference. In this case, the intensity of the emergent light is maximum. 2. Destructive interference. This makes the intensity of the emerging light minimum. When light rays fall on a thin film like soap bubble, two sets of rays are reflected from its surfaces. The interference of these rays depends on the thickness of the film, the wavelength of the light, and the angle of refraction, which in turn depends on the angle of viewing. If the red color produces constructive interference at a particular point of viewing, it will appear as a red spot. In the same manner, when a blue color produces constructive interference at another spot, then it will appear blue. The variation of angle of viewing makes the colors to change. This phenomena is responsible for the beautiful colors produced on the surface of the soap bubble or an oil film or a compact disc. Colors are related to wavelength. Wavelength of the waves are inherently related to its energy density, variation of refractive index, and many other factors. These variations can be suitably analyzed and detected by modern sensors. For example, the absorption of a particular color by a glassy material can be detected using an optical spectrophotometer. This spectrograph reveals the absorption of a particular wavelength. The variation of wavelengths can be suitably converted into some mode of perceptible variation, such as musical notes and tactile inputs. This will enable a visually challenged person feel the presence of color and experience the mystifying colors of nature. For instance, we can enable a visually challenged person to experience the feelings of watching and viewing the beautiful rainbow and the wonderful colors in it. In this scenario, if this hypothesis becomes realistic, it will be possible to empower and enable a visually challenged person to see the beautiful world. Next time, if you came across a person who is deprived of seeing, think, how would you enable him to see the beautiful world around him?